Start. Welcome participants of micro irrigation engineering subject. Dear participants, we have completed 4 weeks of this course. This course started in the last week of July 26th, and altogether more than 1100 participants have joined this course. In the last 4 weeks, if you look, we have conducted classes related to the basic fundamentals of fluid mechanics. We have let me put it, we completed in the week 1 introduction part of the micro irrigation. We did fundamentals of fluid mechanics. We completed soil water concept, soil water constants, and on these 4 topics which I told you, we made some numerical problems and that we solved in this particular week. In this week, there are some participants. They have raised some questions. I am very happy to see that some of you are very active and you had been putting questions, though I was trying to answer you for the individual, but I found that instead of answering those questions at individual level, I thought let it be shared to all of you, those who are attending this live session. The first question is by Mr. Rahul Singh. He addresses the question that it is soil moisture content and gravimetric water content are different. Yes, both are soil moisture content, but when we express gravimetric moisture content, it is referring to the water content on weight basis. He then further writes, you have used dry solid weight in moisture content and that has been expressed in percentage. How dry soil weight of the it is in gravimetric water content which has been given in the slide. This is the question he has given. So Mr. Rahul, your question is that how the soil water content and gravimetric water content, these are different. Both are soil moisture content, no doubt, but gravimetric moisture content, as I told you, it is expressed on the weight basis. Soil water content, it can be expressed volumetric basis or weight basis. Here in the gravimetric means measurement is then done on weight basis and we are expressing amount of water or weight of water or mass of water with respect to the dry soil. What is the weight of the dry soil? And we express in terms of percentage. So we multiply the weight of water divided by the weight of dry soil multiplied by 100. It gives the in percentage. Now when we want to express soil moisture content on volumetric basis, then what we do, we use this value gravimetric moisture content multiplied by the bulk density of the soil, considering the density of water as 1. So we will get what is the water content in terms of the volumetric basis.
Can we intervene in between?
No, sir. Please,
okay.
Please write your question on chat box. We will clear your question.
Okay.
Second question, same gentleman, Mr. Rahul Singh. I appreciate that he has raise question that why osmotic potential won't be zero in the absence of salt concentration. Osmotic potential, it refers to the salt concentration in the water. It is expressed in the salt concentration of the water. So it will be zero when water without salt concentration means pure water, it is zero. The third question is also by Rahul Singh. He writes I am not able to understand the soil water content graph, how it has been plotted, and he writes there is a value of Ks at y-axis. What is on x-axis? What is meaning of Ks? It increases. What is meaning of it? Does it mean that there is a less water for plants or otherwise? Well, very good question. The Ks, it is expressed as a soil moisture stress coefficient. This Ks, it is mainly referring to the availability of water in the soil. Now, the question which has been asked here, where no values are given as far as the moisture content is given, but this is the actually on the x-axis. In the x-axis, it is the soil water content. Now, this soil water content, it is expressed, when the soil water potential is zero, means when it is saturation, but from saturation to field capacity, this water is not useful from the plant growth point of view. So whatever moisture available from field capacity to a particular level of soil water content, this soil water content, we call it as a critical soil water content, critical soil moisture content. Now, this soil water content is readily available water where stress is not there. So Ks value from the field capacity to the critical soil water content is 1. As the soil water content depletes, or we can say during the plant water extraction process, or during soil evaporation process, the value of soil water moisture content will decrease, and it will proceed toward the lower soil water content, and it may go up to the wilting point. Wilting point means plants are no longer able to extract water from the soil. So here the total water available from field capacity to the wilting point is total water available, all available water. But this total water, when it reaches to the wilting point, means beyond wilting point, plants are no longer. So this part is readily available water, and this part is a total available water. Now the value of Ks, what it is asked that the value of Ks, it influences the evapotranspiration process. Means when soil water content in the soil, it is less, the value of Ks will decrease. Value of Ks will decrease. So it also influences the evapotranspiration process. This also influences the crop coefficient process. So crop coefficient will decrease. That is what you are seeing. It means the value, it could be 0 when the soil is we can say soil is dry, means there is a soil is completely dry, the Ks could be 0 and it could be very high as 1. So here means it is the soil is at field, soil water content is at field capacity. So Ks is the soil moisture content coefficient, and this Ks is equal to 1. If it is less than 1, we say that it is water limiting condition, and the value of Ks is used as a multiplication factor to determine the crop coefficient. The next question is by Mr. Madhukar Chavan, Dr. Madhukar Chavan. He writes how to calculate the elapsed time for infiltration. Madhukar Chavan, it is the graph which has been plotted. You can see here is the graph when it is plotted, it is between this time which is given in the x-axis, it is elapsed time. Now these are the observations. When we are getting the observations, already I have explained you in the slide, in the presentation. This only, I have taken only that particular slide where you have raised the question. So that only this particular slide is shown. This is for all participants. Only that particular slide I am showing where the question has been asked. Otherwise, full detail about your question on a particular lecture, it has been explained in the main presentation in the course. Now this x-axis is elapsed time. Practically it is elapsed time, means 0. This is a 0.5 hours, means 30 minutes. So cumulative value, these are all nothing but the cumulative value of the time. Now cumulative value of time is nothing but the time elapsed or time passed. So at 1 means when 1 hour has passed, it has, let us you can see here that this particular graph, there are two graphs which has been plotted. One is the cumulative infiltration, another one is the infiltration rate. This one is the infiltration rate. So cumulative infiltration, it is as the time is passing, the depth of infiltration, it is being added, and it takes altogether, and then you will find that the slope of the curve almost it becomes steady. Similarly here also, when you are taking the derivative of this equation, this is the infiltration rate. Now the question is that what is elapsed time? Elapsed time is nothing but the time which has already passed, means that how much time it has passed at that particular time passed. This is the what is the value of cumulative infiltration. Now this is by taking the experimental observation. One can also, suppose we have been given an equation. We have been given equation, and from the equation someone wants to know what is the elapsed time. So equation can be expressed by Kostiakov's equation. There are quite a good number of equations are there where y means yc, that the cumulative depth of infiltration is given by a into t. T is the elapsed time to the power alpha plus b. A and b are the constant. A, alpha and b, all these are the constant, and that can be determined from the experimental values, and t is the elapsed time. So if I have the yc value and a, alpha and b are known to us, one can find out from the equation also what is the elapsed time. I think it is clear to you what I have explained you. The very interesting question which has been asked. Now I'm entering to the week 2. So these were the questions which has come from week 1 lecture, means from the 5 lectures, which has been delivered in week 1. These were the questions. In second week we have taken up topics on evapotranspiration. We have discussed about how different methods of determining the evapotranspiration. We have found out the crop coefficient and water requirement. We conducted field demonstration of various agrometeorological instruments and how those data which are collected from agrometeorological instrument. They can be used to determine evapotranspiration. And then in this particular week 2 lectures, we have also worked out numerical problem in tutorial. So quite a good number of exercises related to determining the evapotranspiration by various methods have been dealt. Now, one of the way to find out the evapotranspiration is by using the lysimeter. So question has been asked in this particular diagram. The question has been asked why GW is added in expression. Again, this question had come from Mr. Rahul Singh. Thank you, Mr. Rahul Singh, for your interest in the subject, and I appreciate that you are going through the topics, all the topics very seriously. Therefore, we are asking question. So how GW is added in the expression? However, it is a contribution like irrigation and precipitation. You are right. Why, how the, now, so this is the diagram. This is a theoretical or conceptual diagram which is being shown. Now, we are taking a control volume. This is a control surface. Dotted lines are control surface. In the control surface, there are, when we are taking the inflow or input and output. So whatever changes it takes place, it is change in the soil moisture content or soil water content. What are the inflow components? Inflow components are irrigation, precipitation, which is a rainfall or snow, whatever form it is there. And then the other inflow component is the water, which is coming as a surface inflow, or water entering into the control volume. Laterally it is entering, and then water going out of the control volume is lateral outflow. Now, the other component is groundwater component. Groundwater, suppose it is in such a condition, means water table is can contribute by capillary action to the root zone of the crop. So naturally, it is a contributing. Sometime, if you remember, there are, such certain situation where water table is only controlled, and from the water table, irrigation is being given. So sub-irrigation system, it is used, which is one of the standard method of irrigation method, where groundwater table is controlled and irrigation is given to the crop by controlling the groundwater. So groundwater is also one way of irrigating the crop. So whatever you are seeing, the direction which are flowing toward the control volume is a inflow component, and which is going out, say evapotranspiration going out, and the lateral outflow, it is going out, and the water which is leaching out of the control volume, that is as a means you are giving extra water as a leaching part. So are depercolation. So these components are taken as a inflow. So this is what you have asked question, that in the inflow, why GW has been added. This is the equation, which is the change, means inflow minus outflow. So inflow GW is the contribution. Groundwater also, if situation is, say, if our groundwater table is too low, it will not contribute. If the water table is much below, it is not, means the roots are not getting water from the water table. Then only in that case we will use irrigation or precipitation. It will depend upon the particular condition, which component is zero or which component is negligible. Okay, similarly for outflow. So this is the thing. And when you are taking the inflow minus outflow, so this can be equated in terms of evapotranspiration. I think, Mr. Rahul, your question I have cleared. And if you have any question, please put up on this particular thing in the chat. We will answer your question. So let me just come to your next question. So your next question, you write, what is the mathematical relation between lysimeter and sensitivity. Well, lysimeter and sensitivity, these are the two different things. These are the two different things. Lysimeter is a device which is used to find out the evapotranspiration requirement of the crop. Now, how sensitive lysimetric device is? That is the question. That how sensitive the any change, smaller change in the value of gain in soil moisture content or smaller component of the water which is withdrawal by evapotranspiration process, whether it is deflected or it is being shown by the meter, shown by the some device, shown by some certain measurements which is being done. So in this particular, if you remember, when I have given you question. So in this question which I have given you, that we have attached a manometer. Now manometer has been put up inclined. If it is simply a vertical, if it could have been vertical, so whatever change in the value in the vertical value, you will be able to observe that this is the deflection or this is the change in the value. Suppose you have got 5 centimeter is the a particular value. Now the 1 centimeter water, it has been taken by the plant for meeting the evapotranspiration requirement. Now 1 centimeter, how it can be deflected in a more, it can be magnified. So for magnification purpose, this inclined manometer has been used. So this magnification, whatever h you are giving it, if I put it the same thing, in inclined plane, then this change in the value is simply y equal to whatever value you have multiplied by the cos theta. So theta is this particular value when you are taking theta. So this theta which we are using it, that can be utilized to find out the change in the value, which will be magnified value. 5 centimeter you are magnifying only. So that is how the sensitiveness has been, I might have told in the class. Otherwise, the sensitiveness is the value how whatever changes due to, suppose we are adding water or there is rainfall, it has occurred. So smaller quantity of rainfall of few millimeter which has occurred in the lysimeter, whether it is deflecting, it is indicating in the manometer. So that is the important thing which is there. The next question, it is on the it is given, is there any height norms? Question, it is given, is there any height norms at which each of the instrument need to be placed, and how is wind speed recorded? Height norms, you are referring to the agrometeorological equipment. Well, there is there are standards which has been fixed for all the equipment, at what site what should be the spacing from one equipment to the other equipment, and what should be the location. It should not be interfered. So India Meteorological Department, IMD, India Meteorological Department, IMD, Pune, head office is located in Pune. Similarly, there are other world, organizations, say US Weather Bureau. These organizations, they have given a specification for installing different gadgets in agrometeorological observatory. Now, when we are recording the wind speed. So for wind speed, the wind speed, it is measured at with the standard of 2 meter height. That is a standard, it has been prescribed. So if wind is, wind is measured, say at a particular place, it is measured at any other height. So there is an expression to convert wind speed at that particular height with respect to 2 meter. So I would suggest you already, in the lecture notes, already in the presentation, I have given reference of FAO 56, Food and Agriculture Organization, that 56 is the nomograph, it is the manual where all the formulae which are dealt for finding out the evapotranspiration requirement of crop, that it is dealing with all the gadgets also, and then there is an expression that has been given, and that you can refer it from that book. Mr. Rahul Singh, he asked, in my region, we received 1200 millimeter total rainfall in a year. And in 3 months of paddy season, how it uses 1200 millimeter of water. I am not getting this water calculation for the crop. Say water requirement and rainfall. Water requirement and rainfall, these are the two different things, Mr. Rahul. So here 1200 millimeter rainfall, it is a representative value. This is not 1200 millimeter amount of water needed by the crop. It is not a standard value, I should say. It is the value, it will change as per the agroclimatic region, as per the soil, as per the specific variety, and in which season the crop is being grown. That is one thing. Now, amount of rainfall which has occurred, which is occurring in a year, part of that rainfall will be a contribution if the crop is grown in that particular season. So that will contribute, but one has to add additional water. One has to add additional water to meet the evapotranspiration or water requirement of the crop. So this could be surface water from the river, from the lake, from the pond. It could be any source, and that water is given by using a appropriate method of irrigation, and you are using a drip irrigation. So that way one has to use a particular method and use source. Rainfall, yes, that will be subtracted from the total water requirement. Whatever additional water which is needed, that has to be supplemented by using the water which is a surface water or groundwater. So these were the question from the week 2. Questions which has come in week 3. Week 3 actually, again, we had 5 lectures, 4 lectures rather, I will say, and lecture 5th was, and that is on tutorial 3. So in week 3, we had irrigation scheduling. We completed soil, plant, water monitoring instruments. We also discussed about how to measure irrigation water. We also dealt with the irrigation efficiency, and on all these 4 topics, we solved numerical problems which were on these 4 topics. Okay, so on these particular topics, Mr. Rahul Singh, again, his question is, he asked, not all capillary water is available to plants. Please explain more. Mr. Rahul, capillary water in the micropores, capillary water in the micropores of the soil is held against the force of gravity. Means whatever free water or gravitational water which has been removed by the force of gravitational, so water which is left as a field capacity, that is the water which will be as a capillary water. Now it is this particular water which is held by the soil pores due to the cohesive and adhesive forces, and most of this water is available to the plant. However, some part of the water, it is held so rigidly that the force of gravity is unable to separate it from the soil particles. Hence, part of the capillary water may not be available, or which is held so rigidly by the force of adhesion. Adhesive forces are, whether it comes to the stage where the gravitational force is unable to pull it, or roots are unable to extract, so that water is not available, even though this water is available in the soil pores. So that this is the meaning of that not all capillary water which is available, which I have told in the class. This is the region I told that, yeah, water is available. This is the available water which we are telling, readily available water. But frankly speaking, some water, it will remain in the soil pore, that will be held so rigidly that force of gravity will not be able to separate it. The another question, is there any relationship between plant available water, that is a PAW, and capillary water? Yes, plant available water are available, but sometimes we call it as a available water. This exists relationship, and this is given by PAW. This is what I have given in this slide also, the same slide I am showing you here. The amount of water held in the soil that is available to the plant is the difference between the field capacity and permanent wilting point, that this water is your plant available water or total available water. Just now I have explained you. The next question is by Mr. Matthew P. Jacob. He asked, and the slide I am giving here, he tells which of the instruments, these instruments are used to find out water availability in the soil by water diviners. the groundwater diviners, it is just prospecting the groundwater, that is by guess. It's not a scientific method, but in our Indian, there are some people, they use this technique for prospecting or for assessing what is the possible way how to find out the where is the possibility of getting groundwater, but no scientific way of pointing out or finding out the location that it is a correct. It is the resistivity method. There are other methods where the resistivity of the rock or the groundwater possibility, it is found out. But yes, sometime people, they are also telling using some of the companies, they manufacture, they have given a term as a they are using a term called soil water diviner. Soil water diviner, which is similar to the time domain reflectometry or field domain reflectometry, which I have discussed in the class. So that device is used for soil water content or Wados zone soil moisture content. It is not used for finding out the groundwater. The Mr. Vallal Kannan, I thank him for pointing out the one error in the slide. I use this particular expression for finding out the conveyance efficiency. EC equal to VF by VD. VF was the volume of water delivered to the farm by irrigation system, and VD is the volume of water diverted from source to the irrigation system. So as such, this expression is good, but when I was defining the symbol, I wrote here EA. That was the typographical error. Thank you very much, Mr. Vallal Kannan, for pointing out this error. This I have corrected in my slide. Mr. Kannan, you have pointed out on this graph. I also appreciate for keenly watching the videos and the pointing out the errors, typo errors, and that part I appreciate, and I have corrected here also that the value which you have given, that it should be the 3.5 to 3. So this already I have corrected here. The adequacy is decreased when we are using these two curves, that is for a particular system irrigation which is done, that is for A and B. So this particular thing, the value is changed from 3.3 to 3.5 to 3 at constant uniformity. I appreciate. Thank you very much for pointing out this mistake. Another question which has been asked, that it is a very good question, that it is given here by Mr. Rahul Singh. He asked, sir has told in his example to distribute the 1 hectare field. He writes field, but it is a field. Of course, I think it is a typographical error from his side. 1 hectare field, say 10 part, and get the infiltration value in each plot. My question is, while taking the infiltration reading in saying nth part of the field, he writes field. So nth part of the field, should we have to add value of infiltration n minus 1th field? And is that cumulative value of sir referring to here? Is my understanding of cumulative value of infiltration is true? So I would say you have not understood the thing. What I have told, it is not the cumulative infiltration. It is the cumulative area. It is the cumulative percentage area. Please see the graph. In this graph, this is the cumulative percentage area. Means area is, say, whole area, let us say that 1 hectare. So I am taking observation from 1.1 hectare area, 0.1 hectare area, means like this. And these are cumulative which has been made, and what is the depth of infiltration which has occurred. So total cumulative depth of infiltration has been not cumulative. This is the depth of infiltration. So same amount of depth of infiltration data which has been plotted. So it is not the cumulative infiltration, but it is a cumulative area. So to determine adequacy of irrigation, the graph has been prepared. This graph shows cumulative frequency distribution pattern of infiltration depth of water versus cumulative percentage of the field area. The next part question is by Mr. Kannan. Can you post formula with author for water productivity calculation? Well, in fact, these two terms, earlier most of the erstwhile presentation, in my presentation I have also used the conventional presentation I made, where the water use efficiency term has been defined. But what happened now, the water productivity term is being used. So water use efficiency and productivity these are the two terms. And these are two different terms. And both terms do exist and both have different definitions and applications. Efficiency, when we say, efficiency refers to the work performance, or simply explained by output and input ratio. Productivity refers to what one can produce from unit input. So it is also ratio of output to the input, but both do not need to have same unit. This is the thing, that not necessarily in case of productivity, it is going to be the same unit. Whereas in efficiency, your numerator and denominator, it should be of same unit, and when we need to multiply it with the 100. So what happened? The crop water use efficiency, which I have given you, is nothing, means what I have told you, this is water productivity. So crop water productivity is it is given by Y by ET, that is a crop water productivity. Okay, and if I am using, I can say, if I have used say 10 millimeter of water, or 1 centimeter of water, I can say, out of which 8 millimeter of water is used by the plant, and 20 millimeter of, or 2 millimeter of water, it has gone as evaporation, or it has gone beyond the root zone depth. So if I put it 8 by 10, 8 millimeter by 10 millimeter, it will be your the water use efficiency will be 80%. But from the crop point of view, how much yield it has, it has given out of the how much amount of water which has been supplied. So it is a crop water productivity when we are using evapotranspiration. So we can say water productivity with respect to evapotranspiration, water productivity with reference to water requirement of the crop. I think I have cleared your doubt, and thank you for pointing out this also. This is also one of the important thing which is discussed by agronomists and engineers. They always, put it this term, and sometime, it goes in a different meaning. So water use efficiency and productivity, they are being cleared, I think. And this is, and you have asked about the particular reference that whom. So here it is given, this particular reference. You can read that by Narayan et al. 2014. In his paper, he writes water use efficiency and water productivity in Spanish irrigation districts of your Rio Arja, the International Journal of Agricultural Policy and Research. In fact, quite a good amount of literature is available on this topic. You please go through, and then your doubt will be cleared. Now I am entering to the week 4. The question it has come means I am just addressing the question which I received some time back, and I am then right now for today's class I will discuss more about this part. So in week 4 we discussed the introduction of water lifts and pumps, variable displacement pumps, irrigation water quality, and then we have worked out numerical problems related to this lecture that is in the tutorial, that is given as a title as a tutorial class 4 on pumps, irrigation water quality and introduction. And irrigation method is also in week 4. From week 4, one question, it comes from Mr. Karthik. Mr. Karthik, he asked, if we use saline water, then the emitters get clogged easily. And it must cost more for users. Then why we are using that? We are doing it for management of pure water. It's okay, sir, but using saline water is suitable or not? Mr. Karthik, thank you for your question. We are dealing, when we are talking of water scarcity, and particularly in water scarce region, you may find there is a water salinity is also a problem. So in order to use the saline water, surface method of irrigation has problem because you are flooding the whole field. In case of drip irrigation system, you can use saline water to a certain extent. I don't say a very high value of salinity. So 4 deci per millimeter is recommended. And some of the crops like brinjal, egg crop. So it is giving, a response as compared to the fresh water or sweet water. It gives a better response with saline water also. And when you are applying water to a certain level of salinity, what happened with the drip system, the salinity, because it is a drop by drop water, when it is being implemented, what happened? Salts are pushed out. The higher concentration salts are pushed out, and then what happened? The near the root zone, there is a salinity, means lesser salinity there, and plant grows. So particularly for water scarce region with salinity, I would say yes, one can grow crops rather than using a fresh water or not growing crop. Now here, the salinity part, when I'm showing you this particular table, and this table I have taken it from the slide which from my video presentations. So in their presentation, there are 4 labels, labels of salinity which has been given. So you can see here the salinity for surface irrigation system up to 2.25 decisiemens per meter. It can be used for irrigation, but drip irrigation can go far. One can go little higher also. Yes, one need to manage, means one has to keep flushing drippers and use those drippers which are clogged, which has got less clogging problem. I see at IIT Kharagpur, I can tell you we have developed a dripper, and still my research is going on, which is working at a low pressure. The low pressure dripper we have developed, which is working, which requires lesser pressure. And also in the coming lectures, Mr. Karthik, you will see in the coming lecture, we will be showing you the how to develop a dripper, and how the dripper which we have developed, it is superior to the existing commercially available dripper. Now this dripper, we are looking for some partnership, some industries to come forward and help us to multiply and bring it to in the market. So these are some questions which I have received, and then from the chat right now, based on the presentation, when I'm giving you the live, the session. In this live session, Mr. Girish Chandra, he has explained about the infiltration index. Well, infiltration index, this is a phi index and W index. Okay. Now these two indices, which I have told, I'm telling you, this phi index or W index, these are meant for hydrologic studies. Let me tell you, for hydrologic studies, do these two. For irrigation point of view, we do not need this index. So when you are plotting, say, the rainfall data, rainfall hydrogram, rainfall heights when you are plotting, or rainfall intensity you are plotting, and then there will be one particular constant rate of infiltration, that is what we call it as a phi index. Now this phi index will vary, and there will be one particular value. The amount of rain means your the infiltration means, we will say that constant rate of infiltration, and that, so whatever excess value it will be, that will generate as a runoff. That runoff is used for design purpose, okay, for finding out or developing the direct unit hydrograph or direct hydrograph. There we are using the this particular type of study. So it is not relevant to this particular study, that is for irrigation purpose. For irrigation purpose, normal we go for normal infiltration test by using the double ring infiltrometer, or simply infiltration rate equation is used. That infiltration rate equation is used to find out what is the constant rate of infiltration, and that basic rate of infiltration is used for design purpose of irrigation system. The other suggestions which I have received from the participants, one gentleman, Mr. Robert Bolaku, he is from Uganda. He is suggesting, can you please include surveying for irrigation engineers in the course to help us in enriching our knowledge in topographic surveys for irrigation projects? Mr. Robert, I welcome your suggestion, and maybe we will include because when we are installing the system, irrigation system, particularly this is a micro irrigation system. So at that time, irrigation survey, irrigation labels are important when we are designing the system, when we want to find out what will be the head requirement. So this is a good suggestion. I think in this particular course, when we will update this course in the next year, because this time now it is not possible to include, but next year certainly I will take care, and your suggestion we will take care for this. There is another question. It is given in solution of this is Mr. Bosang Gauda Ronald. He is actually, we are actually putting for each means there are 12 assignments. So there are assignments. In assignment, some suggestion it has come, and he is telling in the solution of question 7 in assignment 1, porosity answer is given 0.475655, which has been the correct answer is 4757. So what he has suggested, why it should have been given in the range, I fully accept your things, and we will update this thing to our NPTEL office to update, and your question, your suggestion will be well taken care of. I have used Mr. Robert Baluku again. He from the Uganda. He is questioning that I have used in some places. I means lakhs, crores, this kind of things at the time of presentation I have given. I fully agree with you. I will put up these things in millions or billions, whatever appropriate unit it is there, instead of giving in lakh, because this particular course is not only for our Indian students, this is for the international students. All the students, they can participate. Your suggestion will be taken care. We will certainly take care of your suggestion. The another question, it has come in the chat, which I see here. Explain non-recording rain gauge. I have request for the participant. Your questions will be entertained only when you are putting question in the chat, because this is being recorded. This is thank for that. Please do not intervene and do not ask question directly, because this is the system of NPTEL. Question is, explain non-recording rain gauges. The question is by Mr. Brajesh Tripathi. Thank you, Mr. Tripathi ji. This is the question, non-recording type of rain gauge. It is a Simon's rain gauge. So it has got a 12.7 or 127 millimeter diameter funnel. So whatever amount of water which falls, rainfall it occurs, it comes and it is recorded by the sampling bottle, and then sampling from the sampling bottle there is a measuring cylinder, and whatever amount of rainfall it occurs, that is in the volume, that particular cylinder or bottle, it comes, it is measured with the standard gauge, and that gauge value is given as the rainfall occurred in 24 hours. This is a very simple device, and this is used by IMD. If there are any other question in the chat, you are free to write in the chat that this is the way to answer. I will be happy to answer your question. So friends, thank you very much for attending all my 4 weeks lectures, and from again we will be meeting you after completing the 8 weeks. So 9th week sometime date I will give. So we will again meet, and whatever questions are there from 5th week to 8th weeks, we will address your question. Thank you very much. You have really taken all the very good suggestions I have got, and this will really enrich my course, and this will also help me. Thank you very much.
Thank you very much, Tiwari, for so useful talk. I think